So this is lesson 9. We continue with section 3.2 on basic differentiation rules and rates of change. Are there any questions about homework problems or anything that we've covered so far? Yes, no? Okay, so let's review a little bit about the derivative. So if we have a function, y equals f of x, and the graph, let's say, looks like this, then at a point on the graph, let's say A, let's say the value of the function is b, so f of a is equal to b. And we want to have some idea about how slowly or rapidly the function is changing at this point. So if I take a point a plus, let me just call it a plus delta x, move a little bit, let's say, to the right. Here's the corresponding point on the curve. So this point has coordinates a comma f of a, and this point has coordinates a plus delta x and f of a plus delta x. And if we draw the line between those 2 points, that's the chord. This chord has slope rise over run. So f of a plus delta x minus f of a, that's the change in the height. And the run from here to here is delta x. So this is the average change as you go from a to a plus delta x. And the derivative, f prime of x, is something like the instantaneous rate of change. The limit as delta x goes to 0, so f prime at a, of f of a plus delta x minus f of a over this delta x. This is the derivative. And we have different interpretations of what this means. This is, first of all, the slope of the tangent to the curve y equals f of x at the point x equal a. And it's also equal to the rate of change of f of x. So as you go from a to a plus delta x, this quantity is the average rate of change of the function, and this is the instantaneous rate of change. So these are the two fundamental interpretations of this limit. This limit is the derivative. And in lesson 8, we proved certain properties of the derivative. And these properties allow us to compute the derivative in many cases. So the first is the constant rule. If f of x equals c, this is the constant function. So the graph is just y equals c, this horizontal line. The slope of this line, well, the tangent to this graph at any point is just the line itself. And a horizontal line has slope 0. So f prime of x is equal to 0 for all x. So that's the first and the simplest differentiation rule. Okay. The power rule is extremely useful. I mean, this rule you really use all the time, and that's an understatement. This is the power rule. where f of x is a power of x, x to the n, for some n. And the derivative is n x to the n minus 1. If you differentiate x to the power n, you get n x to the n minus 1. So for example, f of x, that's x to the first power. That's 1 x to the 1 minus 1, which is 1 times x to the 0. X to the 0 is 1. So the derivative of x is 1. So this is the case n equals 1. In the case n equals 2, f of x is x squared. Oh, sorry. If f of x is x to the first power, I should say this implies f prime of x is 1 times x to the 1 minus 1. If f of x is x squared, so n is 2, then f prime of x is 2x to the 2 minus 1, or 2x. If n is 3, so f of x is x cubed, then f prime of x is 3x to the 3 minus 1, which is 3x squared. If n is 17, so f of x is x to the 17th power, then f prime of x is 17x to the 17 minus 1, or 17x to the 16. And in fact, this power rule is true whether n is a positive integer, a negative integer, a fraction, or any other kind of number. So if x is equal to minus 1, f of x is x to the minus 1. X to the minus 1 is 1 over x. That's the way you would often write it. And so f prime of x is n minus 1, x to the minus 1 minus 1. That's minus x to the minus 2, or minus 1 over x squared. Any questions about these? Suppose n is minus 2. So f of x is x to the minus 2, which is minus 1, which is 1 over x squared. So f prime of x is n, that's minus 2, x to the minus 2 minus 1, which is minus 2x to the minus 3, or minus 2 over x cubed. Suppose n is a half. F of x is x to the 1/2. 1/2 means square root of x. So f of x is the square root of x. So f prime of x is 1/2 x to the 1/2 minus 1. That's 1/2 x to the minus a half. A negative exponent means 1 over x to the power, 1 over 2 x to the 1/2, or 1 over 2 times the square root of x. Okay. So from this simple power rule, we get many beautiful formulas for derivatives, like this last one. It says that the derivative of the square root of x is 1 over 2 times the square root of x, okay, which is not at all obvious, but it follows from the power rule in one step. Any questions about this? Here. What is the derivative of x to the minus 2/3? I'll give you a minute to work it out yourself. Can someone give me the answer? So in this case, n is minus 2/3. It's minus 2/3 x to the minus 2/3 minus 1, which is minus 2/3 x to the minus 5/3. That's all you have to do. Any questions about these? All right. So now we have enough technique to solve the following problem. Find the equation of the tangent line to the curve y equals 2 plus x cubed sorry, just making y equals x cubed at the point x equal 1. So it's always good to know what's going on by drawing a picture. The graph of y equal x cubed looks like that. And so it's like we're looking at the function f of x equal x cubed. And x is equal to 1. Y is equal to 1 when x equals 1. So the graph goes through the point 1, 1 in the plane. And we want to find the equation of the tangent line. So what do we know? So the derivative the slope of the tangent line at x equal 1 is the derivative evaluated at 1. What is the derivative evaluated at 1? Well, if f of x equals x cubed, by the power rule, f prime of x is 3x squared. So when x is equal to 1, the derivative evaluated at 1 is 3 times 1 squared, or 3. So the slope of the tangent line is 3. So what do we know about the tangent line? The tangent line has slope 3 and passes through the point 1, 1. Right? It's the line passing through this point. It's the tangent of the curve at this point with slope 3. So we use the point slope formula. The point slope formula says the line through any point AB with slope m is y equals m times x minus a plus b, right? So this formula we use constantly. Okay? And in our case, the point AB is 1, 1. So a equals b equals 1, and the slope is 3. So the tangent line is y equals 3 x minus 1 plus 1, which is 3x minus 3 plus 1, is 3x minus 2. So that's the tangent line. It's a line with slope 3, and the y-intercept is negative 2. So this is my line. Okay. So this is one of the basic problems in Calculus 1. Finding the equation of a tangent line to the curve at a point. Now, another line that's very important is the line that is perpendicular to the tangent line at this point. So the normal line is the name of that line. The normal line is the line through the point 1, 1, perpendicular to the tangent line. Now, what do we know about lines that are perpendicular? The slope of one is the negative reciprocal of the slope of the other. So the slope of the normal line is minus 1 over the slope of the tangent line minus 1/3. So the equation of the normal line will be y equals minus 1/3 x minus 1 plus 1, which is minus 1/3 x plus 4/3. So the green line is given by y equals minus 1/3 x plus 4/3. And it should be in your calculus lab class, you use Maple or whatever other program you're using to find the equations of the tangent line to a curve and the normal line to a curve at a point, and to graph them together and see how pretty they look when they're drawn to scale.
Professor?
Yes.
Eric got kicked out. He was wondering if you could add him back.
Yes. So I'm supposed to be able to get rid of this waiting room. Thank you. Any questions about this so far? This is really basic calculus. This is stuff you have to know thoroughly. Okay. So there are two other very important, all these are, what I'm doing right now are showing the basic rules about differentiation. So we have a rule which the text calls the constant multiple rule. What that means is if you have a function f of x and you multiply it by a constant, so you get c times f of x, the derivative of c times f of x, you can take the c outside the differentiation sign. This is c times the derivative of f of x. So for example, the derivative of 2 over x, this is the derivative of the number, the constant 2 times the function 1 over x. So that's 2 times the derivative of 1 over x. 1 over x is x to the minus 1. So by the power rule, this is 2 times minus 1x to the minus 1 minus 1, or minus 2x to the minus 2, or if you like, you can write that as minus 2 over x squared. So that's an example of the constant multiple rule. We have the sum rule. If you have two functions, f of x and g of x, and you add them, the derivative of the sum is the sum of the derivatives. And we have the difference rule, which says if you take two functions and subtract one from the other, the derivative of the difference is the difference of the derivatives. So using the constant multiple rule, the power rule, the sum rule, the difference rule, we can differentiate, find the derivative of any polynomial. So for example, if f of x is equal to x cubed minus 4x plus 5, f prime of x, that means the derivative of x cubed minus 4x plus 5, that's the same as the derivative of x cubed minus the derivative of 4x plus the derivative of the constant 5. The derivative of x cubed, let me do this in two steps. This is the derivative of x cubed minus 4 times the derivative of x. The derivative of a constant 5 is 0. The derivative of x cubed is 3x squared, and the derivative of x is 1. So this derivative is equal to 3x squared minus 4. You differentiate term by term using the sum and difference rules and the constant multiple rule, and the rule that says the derivative of a constant function is 0. Here's another example. Suppose f of x is 7x to the 4th minus 2x cubed minus a half x squared plus 19. So I'll leave this for you right now. Compute the derivative. Take a minute to figure it out. Okay. Questions as you do this? I'm just checking attendance as you did this. So there's someone who's online as Zena's phone, but I can't mark you as attending unless I know what your name is. Yeah, okay. So how do we differentiate this? 7x to the fourth is 7 times the derivative of x to the fourth, which is 4x cubed, minus 2 times the derivative of x cubed. By the power rule, that's 3x squared, minus a half times the derivative of x squared, which is 2x, and the derivative of 19 is 0. So we get 28x cubed minus 6x squared minus x is the derivative. Okay. Questions about this? If not, sine, cosine, and exponential. So we've worked out the formula for the derivative of the sine, and because it uses one of the basic limits in calculus, let me just do it again. We want to compute the derivatives of sine x and cosine x. So to find the derivative of sine x, we want to take the sine of x plus delta x minus the sine of x over delta x, and take the limit as delta x goes to 0. And one way to do that is to use the addition theorem for the sine. So the sine of x plus delta x is sine x cosine delta x plus cosine x sine of delta x. So if we take sine of x plus delta x and we subtract sine of x, let me write it like this. I'll just rearrange it a little bit. So this is, well, I'll do it. Sine x cosine delta x plus cosine x sine delta x minus the sine of x. I'm going to write this as cosine x times the sine of delta x. And then I have a minus sine x and a plus sine x cosine delta x, which I'll write as cosine x sine of delta x. And I'll factor out minus sine x from these two terms. I get 1 minus cosine of delta x. So the sine of x plus delta x minus sine x is equal to this. Is this equals this. So what happens when I divide by delta x? This is the limit as delta x goes to 0 of this expression, cosine x sine of delta x minus the sine of 1 minus cosine delta x divided by delta x. Let me actually write it down here just so there's more room. So the sine of x plus delta x minus the sine of x divided by delta x, I get this expression divided by delta x. I can write that as cosine x sine delta x over delta x minus sine x 1 minus cosine delta x over delta x. And we recall the two basic trigonometric limits. The limit as delta x goes to 0 of sine delta x over delta x is 1, and the limit of 1 minus cosine delta x over delta x as delta x goes to 0 is 0. So when I take this limit, I get cosine x times 1 minus sine x times 0. So this equals cosine x times 1 minus sine x times 0, which is just cosine x. So this proves the very fundamental theorem, if you like. The derivative of the sine of x is the cosine of x. This is one of those facts from calculus that you must know forever. Of course, you'll use it constantly in Calc 1, Calc 2, and any other higher mathematics class you might take. Okay. Any questions about this? Okay. And how do we prove the derivative of the cosine? So we have to remember and use the addition formula for the cosine. The cosine of the sum of two angles, in this case, I'll call one x and the other x plus delta x, is cosine x cosine delta x minus sine x sine delta x. So the cosine of x plus delta x minus the cosine of x, let's see, what is that? I have this term, minus sine x sine of delta x, and I have this minus the cosine, minus cosine x, 1 minus the cosine of delta x. So you need to actually check that this is correct. I just subtracted cosine x and rearranged this a little bit. And what happens when I divide by delta x? I get that. So we have that the derivative of the cosine of x is the limit as delta x goes to 0 of minus sine x sine delta x over delta x minus cosine x 1 minus cosine delta x over delta x. And x is fixed, only delta x is changing. So sine x and cosine x, these are like constants. So this is minus sine x times the limit as delta x goes to 0 of the sine of delta x over delta x minus the cosine of x times the limit as delta x goes to 0, 1 minus cosine of delta x over x. This limit is 1 and this limit is 0. So we get minus sine x times 1 minus cosine x times 0 is minus the sine of x. So I've just proved again the differentiation rule for the cosine. The derivative of the sine is the cosine. This is really very important because it's easy to forget. The derivative of the cosine is not the sine, it's minus the sine. So we now know the derivative of the sine and the derivative of the cosine. And the last differentiation formula that we prove in this section is for the exponential function. So remember, we have the number e, which is 2.718 something, one of the fundamental constants in math and physics and every other science, in economics and everywhere else where you use mathematics. And there are many different ways to define it. One way is as follows. This is the limit as delta x goes to 0 of 1 plus delta x to the power 1 over delta x. So this is really very subtle because on the one hand, as delta x goes to 0, 1 plus delta x goes to 1, and 1 to a power is 1. On the other hand, the power isn't fixed, it's 1 over delta x. So as delta x goes to 0, this power 1 over delta x is going to infinity. We have something approaching 1 raised to a power going to infinity, and somehow there's some cancellation or something. So this limit exists, and this limit is, by definition, so you have to prove this limit exists. That you would do in advanced calculus. But it does exist, and we call that e, and we can use that to compute the derivative of the exponential function. So how do we do that? So if we let f of x be equal to e to the x, then the derivative of e to the x, this is the derivative of f of x. It's easier to use this functional notation. This is the limit as delta x goes to 0, f of x plus delta x minus f of x over delta x. This is the limit as delta x goes to 0, something divided by delta x. This is f of x plus delta x is e to the x plus delta x, and f of x is e to the x. And you remember the laws of exponents. If you have any number a to the exponent, or let me use a different thing. If you have any number, let's say z, to the power a plus b, that's z to the a times z to the b. And here I have e to a sum of powers. So this is the limit as delta x goes to 0. E to the x times e to the delta x is e to the x, e to the delta x, minus e to the x. That's the limit as delta x goes to 0, I can factor e to the x out of the numerator. X is fixed. This e to the x is a constant. So this is e to the x times the limit of e to the delta x minus 1 over delta x as delta x goes to 0. So at this point, the book uses something we will really prove much later, that when your exponential function is e to a power, e to anything t is approximately 1 plus t for t small. So I have e to the delta x. This is approximately the limit, e to the x. The limit as delta x goes to 0. E to the delta x is like 1 plus delta x minus 1 over delta x. That's e to the x. The limit is delta x goes to 0. The ones cancel, delta x over delta x. This is just 1, is e to the x. So this is a proof of the third sort of sophisticated derivative in this section. The derivative of e to the x is itself. So these are three, if you like, sophisticated derivatives that we need to know. The derivative of the sine is the cosine. The derivative of the cosine is minus the sine, and the derivative of e to the x is e to the x. Okay. Questions about this now? If not, then let's look at one of the basic applications or interpretations of the derivative, which is as a rate of change. So suppose you have some object and s of t is the position of the object at time t. So the example most books start with is the following. You have some building, which is a certain height, let's say 100 feet high, and you drop something like a billiard ball. I don't know why they like billiard balls, but they always like billiard balls. And it falls to the ground. So the position at time 0 is 100. It's 100 feet up. And as time increases, s of t decreases because the ball was falling to 0. And when it hits the ground, it stops, and it's just s of t is 0 from that time on. So suppose the position at time t is given by a function which is minus 16t squared plus 100. Where this comes from is that if you're dropping this ball in a vacuum, so there's no air, so there's no air resistance or wind resistance. The only force on the ball is gravity. gravity in feet per second, the acceleration due to gravity is minus 32 feet per second. So we'll see later how this, you get from 32 to 16, half of it. But if you just drop the ball at a height of 100, the position at time t is minus 16 t squared plus 100. So when you drop it, it's still, and you let it go and it falls. So for example, what is the average velocity? Velocity is the rate of change of the position. The average velocity from t equal 1 to t equal 2. So what is this? So if you're looking at this function as a function of t, this is t and this is s. You start at 100, and as t increases, this thing is falling. It's like a parabola. Then it hits the ground. At t equal 1, it's at some height, s of 1. At t equal 2, it's at some height, s of 2. So the distance it travels from time 1 to time 2 is the distance from s of 2 minus s of 1. It's falling, and this is how much it's falling. And if you divide that by the time interval, 1 second, this is the average velocity. It's the difference between the change in the height divided by the change in the time. So what is s of 2? S of 2 is minus 16 2 squared plus 100. And s of 1 is minus 16 1 squared plus 100 over 1. 2 minus 1 is 1. Let's see, in this, you can see, here I have plus 100, here I have minus 100. They cancel. So what I get is minus 16 times 4 plus 16 times 1, which is minus 48 feet per second. So if you drop this billiard ball from a building 100 feet high, and the only force acting on the ball is gravity pulling it down, its position at time t given by this function leads to this calculation for the average velocity. What we call the velocity of the ball, by which we mean the instantaneous velocity, is exactly, let's say, v of t. It's the derivative s prime of t. And a basic law of motion says the following. So if the position of a particle, a billiard ball or whatever, at time 0 is s0, that's the initial position, and the velocity at time 0 we'll call v0. So this is initial position, and this is initial velocity. Then the basic law of motion says that s of t is 1/2 g t squared plus v naught times t plus s naught, where g is the acceleration due to gravity. And they're different units depending on what units you're using. So if you're measuring position in feet and time in seconds, g is equal to minus 32. If you're measuring g in meters and t in seconds, then g is minus 9.8. So this law of motion is something we'll use all the time. The velocity is the derivative of this. When you differentiate t squared, you get 2t. So the derivative is 1/2 g times 2t plus v naught times the derivative of t, which is 1, plus the derivative of s naught, which is a constant, plus 0. So we get gt plus v naught. And acceleration is a of t is defined to be the rate of change of the velocity. So when you differentiate the velocity with respect to t, you just get g. So in this law of motion, g is the acceleration due to gravity, and it really is the acceleration. If you differentiate this function twice, you get g. All right. Any questions about this? So let me spend some time doing some problems. So this is section 3.2. I'll just start going through some of the homework problems because they're interesting. Number 43. We have the function f of x equals 4x cubed plus 3x squared over x. And we have to find the derivative. Now, this looks hard because this is a quotient of two functions, and we haven't learned how to differentiate quotients. But you can see that you can simplify this. This is 4x cubed over x plus 3x squared over x. X cubed over x is x squared. And x squared over x is x. So this function is the same as this. And this we know how to differentiate. F prime of x is 4 times the derivative of x squared, that's 2x, plus 3 times the derivative of x, which is 1. So we get 8x plus 3. Questions about this? Let's look at number 45. We have the function f of x equals x cubed minus 3x squared plus 4 over x squared. And again, we need to get rid of this x squared in the denominator, so we can just separate this into 3 different terms. This is x cubed over x squared minus 3x squared over x squared plus 4 over x squared. X cubed over x squared is x. Here the x squareds cancel, you get minus 3, and this is 4 over x squared, or I can write that as 4x to the minus 2. So when I differentiate, the derivative of x is 1, the derivative of the constant 3 is 0, and the derivative of 4x to the minus 2 by the power rule, 4, the derivative of x to the power minus 2 is minus 2, x to the minus 2 minus 1. So we get 1, 0, 4 times minus 2 is minus 8, x to the minus 3, or 1 minus 8 over x cubed. Either one, you can leave it either way. They're both correct.
Professor, with the first question, starting with 4x squared over x plus 3x squared over x, the result of that
You mean
should
here?
be 4x. Well, after that.
Here?
Yes. The result of that, should it be 4x plus 3x or?
So 4x cubed over x is 4x squared. 3x squared over x is 3x. And when you so this function is exactly the same as this. When you differentiate this, you get 4. The derivative of x squared is 2x. Plus 3, and the derivative of x is 1. So this is 4 times 2, 8x plus 3.
Okay.
Does that make sense?
Yes, I was just wondering, like, between the two that you just showed where it says 4x, how you got, I'm still confused as to how you got 4x squared over x plus 3x squared over x. I see what you were saying, but I'm just...
Well, so what I'm using here is just the little bit of algebra that says if you have a plus b over c, that's the same as a over c plus b over c, right? So here I have a sum of two things over this, so it's the same as this over this plus this over this. So this rule about fractions that you learn is true for any kind of fractions. They don't have to be numbers.
Oh, that's a 3. Okay, sorry. No, I thought it was a 2. I thought it was 4x.
Up here?
Yeah, that's a 3.
Yeah.
Oh,
That's
okay.
why x cubed over x is x squared.
Okay, thank you.
All right, what about number 47? So the whole point of these exercises is sometimes you have to be a little bit tricky. So this is x times x squared plus 1. This is a product of two functions. In the next section, we'll learn how to multiply a product of two functions, but we haven't learned it yet. So how do you do this? Well, you can just distribute across. This is the same as x times x squared, which is x cubed, plus x. And so dy dx is the derivative of x cubed, 3x squared, plus the derivative of x, which is 1. Let me do number 53. So 53, the function f of x is x to the minus 2 minus 2e to the x. So f prime of x is the derivative of this minus the derivative of this. The derivative of x to the power minus 2 is minus 2x to the minus 2 minus 1 minus 3 minus 2 times the derivative of e to the x, which is e to the x. So that's the answer. Okay. All right, let's do a few more. Let's look at number 57. So here we have a function y equals x to the 4th minus x, and we have the point -1, 2. What does this mean? So if you look at the graph of this function, or if you look at the function f of x equal x to the 4th minus x, if we were to call this f of x, f of -1 would be -1 to the 4th minus -1 is 1 plus 1 is 2. So this point lies on the graph of this function. And we want to find the tangent line. To this function at this point. So the slope is the derivative. The slope of the tangent point line is f prime, the derivative evaluated at -1. What's the derivative? Well, if y is x to the fourth minus x, f prime of x, the derivative of x to the fourth is 4x cubed minus the derivative of x, which is 1. So f prime at -1 is 4 times -1 cubed minus 1. That's -4 minus 1, or -5. So by the point slope formula, the tangent line is y equals -5 x minus -1 plus 2. -5x minus 5 plus 2 is -5x minus 3. So this is a solution of this basic problem. You have the function y equals x to the fourth minus x. The derivative is 4x cubed minus 1. When x is equal to -1, you get -4 minus 1, or -5. So the slope of the tangent line to this curve at this point is -5. So if you use the point slope formula, the line through this point with slope m equal to -5 is -5x minus 5x plus 3. Oops, -5, just what I wrote, minus 3. -5x minus 3. Questions about that? Let's do another problem. Let's pick one which is on the homework, but a little bit different. This is number 61. So we have the function y equals x to the fourth minus 2x squared plus 3. And the problem is determine the points where the graph has a horizontal tangent line. So we have to sort of really keep in mind what this means. Let's say the graph looks something like this. So maybe if you take a point over here, at that point, the tangent line probably looks like that. It has some positive slope. It's not horizontal. Horizontal means that. If you take a point over here, tangent line will probably look sort of like that. It has a negative slope. Horizontal means the slope is 0. That's what horizontal means. Or mathematically, since the slope of the tangent line is the derivative, it means find the values, the numbers x, such that if we call this function f of x, f prime at x is equal to 0. The points where the derivative equals 0, this gives you the points where the tangent line is horizontal. On this curve, it looks like at this point down here, the slope is horizontal. This point over there, the slope is horizontal. What are those points? Well, to find the points, we look at the derivative. So f of x is the function x to the fourth minus 2x squared plus 3. So this means that f prime of x is 4x cubed minus 4x plus 0. Let's see, I can factor out of 4x. I get 4x times x squared minus 2. I can factor it some more. That's 4x, x minus 1, x plus 1. Oops, sorry. 4x times x squared minus 1. And x squared minus 1 factors into x minus 1 times x plus 1. So f prime of x equals 0. Precisely when x is equal to 0, is where this function is 0. 1 and minus 1. So there are 3 points where this function has a horizontal tangent. In fact, the graph of this function looks something like that. And this would be the point 0, minus 1, 1. And at those 3 points, we have horizontal tangent lines. So here we have this function. We look at its graph. Turns out the graph, fourth degree, usually looks like this. Down, up, down, up. And where does the graph have a horizontal tangent line? Where the derivative is 0, so the slope of the tangent line is 0. So you take this function, you differentiate it. When you differentiate it, you get 4x cubed minus 4x, and we're lucky that factors completely. It's easy to factor. So we get 3 valid numbers, 1, 0, and minus 1, where this is 0. So we get these 3 points on the curve where the tangent is horizontal. Well, this is instructive. Let me do 1 or 2 more. So in lesson 9, the homework is 43 to 61 odd and numbers 101 and 103. So let's look at number 101. So I'll read this problem. It says, you have a building (1,362 feet tall, and a silver dollar is dropped from the top of the building. Determine the position and velocity functions for the coin. Okay, so the initial position as 0 is just the height of the building. The initial velocity, v0, you're not throwing it, so you're not giving it any initial velocity, you're just letting it go. So the initial velocity is 0. So let's recall the formula for the position of this falling object, S of t. It's a half gt squared plus v0t plus s0. So when we're using feet and seconds, g is equal to 32 minus 32 feet per second squared is the dimension. So a half g is minus 16t squared. The initial velocity is 0, and the height is 1362. So that's our function. That gives us the height, and the velocity is the derivative of the position. When you differentiate this, you get minus 16 times 2t, or minus 32t, plus 0. So this is part A of the problem. Determine the position and velocity functions. Part B is to find the average velocity from time t equal 1 second to t equal 2. So that average velocity, this is equal to s of 2 minus s of 1 over the time interval, 2 minus 1. Denominator is just 1. When s is 2, you get minus 16 times 2 squared plus 1362. When s is 1, you get minus 16 times 1 squared, that's 1, plus 1362. These cancel. I get minus 64 plus 16 is minus 48 feet per second. So in part B, the average velocity is minus 48 feet per second. The instantaneous velocities at time 1 and time 2. So the velocity at time 1 is minus 32 times 1, or minus 32 feet per second. The velocity at time 2 is minus 32 times 2, or minus 64 feet per second. All right. Part D, find the time required for the coin to hit the ground. So the coin hits the ground when its height at time t is 0, right? Because s of t is measuring the height above the ground. The coin hits the ground when s of t is 0. S of t is 0 means, what is s of t? Minus 16t squared plus 1362 equals 0. We have to solve this quadratic equation. So this says that t squared, 16t squared, is 1362, or t squared is 1362 divided by 16. Now, let me do this calculation by hand. What is 16 into 1362? I think this goes in maybe 8 times. 8 6s are 48. 8 1s are 8 is 12. 2, oops, 1362 over 16. 8 sixes are 4. So this is, oh, this is 82. And 16 into 82 is whatever it is, I guess. So 85 and 2/16, 85 and an eighth. So t is the square root of this number, whatever it might be. Square root of 16. This is 1/4 the square root of 1362. That's when the particle hits the ground. Yeah, I mean, that's just what it is. And so it's 9 point something. And the last part of the problem, find the velocity of the coin at impact. So the velocity at impact, well, this is the formula for the velocity. So it's v at square root of 1362 over 4, which is minus 32 square root of 1362 over 4. 4 into 32 is minus 8. So this is minus 8 square root of 1362 feet per second. That's the solution to the whole problem. You don't have to use a calculator to find what the square root of 1362 is. It's perfectly okay to leave it like that. Okay. Any questions about this? Okay, so we just covered all of 3.2 and most of the homework problems. It's good to see them done sometimes in front of you. I mean, it's better to try to do them yourselves, and if you're stuck, look at the answer in the back of the book if it's an odd numbered problem, and look at how I did it if you still can't figure it out with the answer. And if there are any questions, we have class again tomorrow. Wow. So we still have 2 classes this week, but that's what it is. Okay. Any questions about this? Yes? No? Okay. If not, then we are done for today.
Bye, Prof.
Thank you. See you all tomorrow.